Tina slowly, slowly. We be working all day long to push us money. We ain't playing no games. Sabatavi, Ngani.
Good day once again, grade 11. So now we are attempting the questions, the typical exam questions that you normally get in grade 11. So number 1, solve for x. We are given 7 to the power 3x plus 1 equals to 4 to the power 49 to the power x minus 1. Okay, let's do number 1 together. Remember, you can pause the video and try to attempt this question on your own. We have 7 to 3 to the power x plus 1 equals to 49 x minus 1. The aim, guys, here is to make the bases to be the same. Maybe you are asking yourself that 7 is already a prime base, so we are not stressing about 7. So the aim is to change 49 here. So we know that, guys, here I'm going to have 7 to the power 3x plus 1 again. So I have to change that 49 to be a prime base. How do I know the prime base of 49? It's simple. You just press 49, then you press equal sign, then you press shift, then you press fact. It's 7 to the power 2. So then I open the brackets, guys. Then remember, the prime base that we have for 49 is 7 to the power 2. Then outside, we have the power, which is x minus 1. Then we drop again this one because there's nothing we have to change here. Then which law I need to apply here? Yes, you need to apply law number 3. Remember, guys, you don't have to write the reason. I'm just reminding you which law you need to apply. So this is 7. Then this 2 is going to multiply 2 times. So it's going to multiply twice this exponent. So it's going to say 2 times x is going to be 2x. Then 2 times negative 1 is going to be negative 2. Now, the bases of the word are the same. Then we equate the exponent. So it's 3x now plus 1 must be equals to 2x minus 2. Now we have to collect the like terms. So I have to transpose this 2 to that side and transpose this 1 to this side. So we are going to have on this side 3x. This positive 2, when we transpose positive 2 to that side, the sign is going to change to become negative 2. So on my right side, I have negative 2. This one becomes negative 1. So 3x minus 2x, guys, we get what? X. So negative 2 minus 1, we get what? Negative 3. So this is your solution for x. Remember, you can take your answer and go there and verify. If I have 7 to the power 3, in place of x, now we substitute the value that we have, which is negative 3 plus 1. Can you see it's 1 over the big number, which is 5, the big number. Let's try and substitute here. It's 49 to the power. X now is negative 3 minus 1. You will see that the number is still the same, so your answer is correct. So let's move to number 2. Number 2, we are given 3 to the power x equals to 7 to the power x. Right. So how can we solve this question, guys? This is number 2. Let's make a division so that you can see that now we are done with number 1. We're doing number 2. Okay, how can I solve this question, guys? Maybe are you asking yourself, I'm confused. Remember, guys, you have to apply your laws of exponents here. But now, we cannot say that the bases will be the same here because 3 is already a prime number and 7 is already a prime number. Then you need to ask yourself, which number can make the left and the right to be equal? So we know that 0 can make this the left and the right to be equal because anything raised by 0, it's what? It's 1. If I can have 7 to the power 0, will give me 1. If I can have 3 to the power 0, will give me 1. So all in all, what I need to do here, I need to divide both sides. You can divide by 3, you can divide by 7. So I will divide by 7 to the power x. 7 to the power x. So this I have 3 to the power x over 7 to the power x. Here we have 1. Understand? So now we see that here, guys, the powers are the same. So if the powers are the same, we can apply the law number 4. Then I'm going to take out the exponent. So which means inside I will have 3 over 7. So 3 over 7 all into the brackets into 3 over 7 to the power x is the same as this thing, because this x tells me that I'm going to multiply every exponent inside. Okay, so now we have 1. I'm going to set this 1 to be power 0 and say 7 over sorry, this is 3, not 7. 3 over 7. So 3 over 7. Okay, let's write it here, guys. So we said that I'm going to take the exponent outside. Now on this side I have 3 over 7 equals to 0, to the power 0. So we know that anything raised by 0, guys, is equals to 1. So which still give us this. So now the bases of the word are the same. So now we can conclude that our x is equals to 0. So that's your solution. Even if, guys, you said, you will still get the same answer. Since you have 3x to the power 7x, you can divide both sides by 3 to the power x if you want. 3 to the power x. So now this one will give you 1, and this one will give you 7 to the power x over 3 to the power x. Now this is the same as you open the brackets, 7 over 3 to the power 0 equals to then 7 over 3 all raised by x. Now the bases are the same. Still here your x is equal to what? To 0. So that was interesting question, but easy one. So let's do number 3 here. Number 3, guys, were given into 1 over 2 all raised by x minus 5 equal to 64. This is cheap, guys. You can get it to this from this puzzle shop. So I have what here? 1 over 2 to the power x minus 5. Remember, you can pause the video, guys, and try to attempt this question on your own. Can you see that we have 1 over 2? We can write this one in negative form. So which is the same as 2 to the power negative 1 all to the power of x minus 5 equals to. Let's find the prime base of 64. If you press 64, then you press equal sign, then you press shift, then you press fact. It's 2 to the power what? 6. Wow. Happy now because I can see that my bases, they are going to be the same. Which law I need to apply here? Yes, it's law number 3. So I'm going to say negative 1 times x is negative x. Negative 1 times negative 5, that's positive 5. I have on my right side 2 to the power x. Now the bases of the word, bases are the same. We drop the exponent. So I'm going to have negative x plus 5 equals to 6. Now it's simple, just transpose 5 to this side. So you're going to have negative x here equals to 6 minus 5. So then you have negative x equals to 6 minus 5, you get what? 1. Now, you were looking for x, not negative x. What you must do now, you have to divide by negative 1 both sides. So this negative 1 will cancel this negative. So now, a positive divided by negative will always give us a negative. Now we can conclude that our x is negative 1. That's your solution. You can verify your answer, guys. So let's do number 4 here and see what we have on number 4. Number 4, guys, we have 5 to the power 9 x plus 1 equals to 15. Okay, the first thing that you need to do, if you see that 5, guys, is not a matter, is already a prime number, but 9 is not a prime number. I have to change 9 and make it simple, a single exponent. But we have to get rid of this 5 because we cannot perform the laws of exponents with 9 in the 5. So I will divide first by 5 both sides. So this 5 cancel out. Now I'm left with 9x plus 1 equals to 15 divided by 5. We get what? 3. Now we are happy because 3 is already a prime base because we have power 1 here. So let's change this one, the 9, and make the prime base. So it's going to be 3 to the power 2. Then we have x outside plus 1 equals to 3 to the power 1. Now, which law you need to apply here? Yes, it's law number 2. So I'm going to say here is 3, then 2 times x, that's 2x. 2 times 1, that's 2, equals to 3 to the power 1. Now, 311, can you see that the bases are the what? Are the same. So now we're going to drop the what? The exponent, or equate the exponent. So now you just transpose 2 to that side. You will have 2x on your left side equals to 1. Remember the 2 here was positive. When you transpose positive to that side, the sign is going to change to become negative 2. So now you have 2x here equals to, so if you say 1 minus 2, what you get is negative 1. Then you need to find x, not 2x. So I need to do what? To divide both sides by what? By 2. Whatever I do on my left side, I must also do on my right side. So this cancel out. So therefore we conclude that our x is equal to negative 1 over 2. So that's your solution for number 4. Okay. Right. Let's do another questions. Let's see what we have. We are still solving for x. So we have number 1 here, guys. You can pause the video and try to attempt these questions on your own. Remember, guys, some of the questions here, they involve the common factor. So when all the bases are the same, an exponential equation of the common factor type can be identified by looking at the exponents and the constant term present between the exponent. So if we look at number 1 here, number 1, we have 2 to the power x plus 2 to the power x plus 2 to the power x. 2 to the power x equals to 96. This is simple. It's the same because now our prime bases are the same. So now we are adding the exponents. We are adding the prime bases, sorry. So it's going to be 2. We have 1 here. We have 1 here. We have 1 here as your coefficient. So 1 plus 1 is 2 plus 1. Now we have 3 times 2 to the power x. So which means this tells me that I have 2 to the power x. 3 is, I have, I don't know what to explain this, but I hope you can see, guys. So equals to 9x. 96. So what must I do now? I have to get rid of this 3. I will divide by 3. Both sides divide by 3. So this 3 cancel out. So now I have 2 to the power x equals to. So 96 divided by 3. What do we have? Yes, it's 32. So now let's find the prime base of 22. Of 32, we'll say 2 to the power x here is equal to 2 to the power 5. Now the bases are the what? Are the same. Now we can conclude our x is equals to 5. This is easy, guys. Very easy. So let's take number 2. So number 2, guys, we are given 3 to the power x minus 3 to the power x minus 2 equals to 24. Remember, I cannot subtract this because the exponents are not the same. So now here I have to consider the common factor because this thing is not the same with the first one. So what I need to do, I need to split this one. So I'm going to have 3x, 3 to the power x times 3 to the minus 2x equals to 24. Right. What do you have here, guys, common? We all know that we have 1 here, but we can see that 3 3 to the power x is common. So I'm going to take out the common factor, guys, here in this case. So your common factor is going to be 3 to the power x. Understand? Then I open the brackets. If I open the brackets, remember, since we are having the binomial, I must always have two terms inside the brackets. So I'm going to be left with 1 here, because 3 to the power x times 1 will still give me 3 to the power x. Minus 3 to the power negative 2 equals to 24. So here we have 3 to the power x equals to 1 minus, write this in positive form, is the same as 1 over 9 equals to 24. So this is 3 to the power x. If you simplify this, you are going to get here 8 over 9 equals to 24. Then you need to get rid of this, guys. This thing is the same now with the first one, what we get here. So now I need to get rid of 8 over 9. So I have to divide both sides by 8 over 9. 8 over 9. Since this is a fraction, I'm going to put a normal divide and say 8 over 9. This cancels this, guys. Understand? So now you are left with what? 3 to the power x equals 2. So then if you say 24 divided by 8 over 9, can you see that you get 27? So now on your right side you have 27. Now you need to find the prime base of 27. So we drop this one because 3 is already prime base. So if we change this one, it's going to be 3 to the power 3. Now can you see that your x is what? Is 3. So now the bases are the same. Now we can conclude and equate the exponents that x is equal to what? To 3. So that's your solution for number 2. Hope you understand. Then if we go to number 3, number 3 is easy. Again, we are given 10 to the power 2x squared times 10 to the power 10 plus 10 to the power x plus 1 equals to 10,000. Right. So this question is 10 to the power 2 x squared times 10 to the power x plus 1 equals to 10,000. Now, guys, what do you notice about these bases? Yes, the bases at the what are the same. So what must we do? We have to take one base and add the what? The exponent. So I'm going to have 10 and 2x here plus this x plus 1 equal to, now let's write this one as a prime base. So it's 10,000 equals to, then it's 10, then press fact. Can you see that we get what? 2 to the power 4 times 10 to the power 5. Okay, let's write them as it is. You will see the magic. This is 10 to the power 4 times 5 to the power 4. Right. I hope you are with me, guys. You are with me. You are with me. So now this is a trinomial, guys. There's no like terms here. So this will remain as 2 to the power 2x squared plus x plus 5. Then we have a problem here. But this problem is a minor problem. Why I'm saying this? Because, guys, you know that from when we were doing the laws of exponents, we said that if I have 2 to the power x times 3 to the power x, now the bases are not the same, but the exponents are the same. We can apply law number 3 and take one exponent outside, because this exponent is common with this one. So I have inside 2 to the power 3. This exponent tells me that I'm going to multiply every exponent inside, which will bring you back here. Now, if you notice that we have 4 here and we have 4 here. So if I open the brackets and put 4 outside, so applying law number 3, so now I will have 2 times 5 inside. So now we drop this 10, 2x squared plus, so let's change the mark. So, and this is, guys, 2x squared plus x plus 1 equals to, what do you have now inside? 2 times 5, you get what? 10 to the power 1 and a 4. Now you are happy. You start smiling. You start smiling because you see now the bases will be the same. You'll drop 10 to the power 2x squared plus x plus 1. Now, which law you need to apply? This is law number 1, law number 3. So this is 10. So 1 times 4, this is 4. So now, good people, the bases of the word are the same. We drop the exponent. So equate the exponents. We have 2 x squared plus x plus 1 equals to 4. Now we have to transpose the constant to that side. So this is 2 x squared plus x plus 1. Remember, if we transpose 4 to this side, we are going to have negative 4. Now, we must not forget equal sign, because this is equation of exponent. Equational exponent, so equals to 0. So now, 2x squared plus x. 1 minus 4 give me minus 3. Yes, what must I do now in order for me to find the value of x? Now the power degree here is 2, which means I will find 2 values of x here. So guys, I will factorize. You know how to factorize in grade 8 and grade 9. Grade 10 you did factorization. So the factors of 2 is going to be 2x here, and the x, the factors of 3 is 3. So since the c is negative, so the signs in brackets must not be the same. The big factor must take the sign of the what? Of the middle term. So I must put 3 here, because when I add the numbers, I must get 1 also. Then I put 1 here. Then the big factor is going to be this side. Then I'm going to put positive here and put 1 here. Negative 1. So now we can see that 2x, guys, plus 3. If you hide this part, 2x plus 3 will be equals to 0. Or if you hide this part, x minus 1 will be equals to 0. So now you transpose 3 to this side, you will be left with 2x equals to minus 3. What you must do in order for you to solve for x, yes, you must divide both sides by what? By 2. So this cancel out. So therefore your x is equal to negative 3 over 2, right? 11. But you're not done. You're supposed to have 2 values of x there. So we said or, then we come to this one, then we transpose 1 to that side. So if you transpose negative 1 to the left, to the right side, the sign is going to change. So therefore x here is going to be positive 1. So this is your solution for this one. The tricky part that was going to confuse most of learner is this one. That was going to confuse most of learner, but you must remember your laws, guys, the laws of exponents. You must remember them whenever you are dealing with exponential equations. So let's do number 4. Number 4 is very cheap. We have what, good people? We are just playing here. Number 4 is very cheap. We are just playing. So can you see that, guys? I'm solving for x again. I have exponents. Now 3 is already a prime base. So the aim is to make the prime bases to be the same. Let's change 27. So I'm going to have 3 to the power 1 minus 2x. We know that 27 is the same as 3 to the power 3. Now the bases of the word are the same. Now you equate the what? The exponent. So it's minus 2x equals to 3. So you just transpose, guys, positive 1 to that side. So if you transpose positive 1 to the left, to the right side, we are left with negative 2x here. Then you have 3. Then if you transpose positive 1, the sign is going to change to become negative 1. Are we together? Yes. So negative 2 we drop again. So 3 minus 1, you get positive 2. What you must do now, you have to divide both sides by what? By negative 2. So this negative 2 cancel this one. So therefore, my x, we have positive here. Positive divided by negative is negative. Then 2 divided by 2, you get 1. So this is your solution for this one. So let's do the last question. The last question, guys, is number 5. So we have what here? 3 to the power x plus 3 to the power x plus 2 equals to 10. Right, this question, guys, is similar to number 2. But the only difference here is the sign in between the bases. So this one is already a prime number. There's nothing that we can change here. So I'm going to keep 3 to the power x as it is. So, but here, to keep the sign, I need to split this one using law number 1, laws of exponents. So it's going to be 3 to the power x times 3 to the power 2 equals to 10. Now, since I cannot add these exponents here, I have to look at the exponent and look at the coefficients. So the coefficient here is 1. There's no common factor between the coefficients. But when I look at the exponents, there's something common. This is x and this is x. So which means that this base here is common. So I'm going to take out 3 to the power x, then I'm left with 1 plus, then I keep the sign. Since we have binomial here, I must also have 2 terms inside. So I will have 3 to the power 2x, then I close the brackets, equals to 10. Okay, now we are close to the final answer. Now I have 3 to the power x here. This is 1 plus, then we know that, guys, 3 squared will give me 9 equals to 10. Then we drop 3 to the power x, then we work in brackets on the brackets. So 1 plus 9, we get 10 equals to 10. Then we need to get rid of what? Of 10. So if we get rid of 10, we're going to divide both sides by what? By 10. So this cancels out. So we have 3 to the power x equals to 10 divided by 10. What do you get, guys? You get 1. Now you need to ask yourself, if you have 1 here, what you must do in order for you to make the bases to be the same. So we know that, guys, anything to the power 0 will always give me 1. So I'm going to say 3 to the power x equal to 3 to the power 0. So this thing is already is the same as 1. Now the bases are the same. Now I can conclude that my x is equal to 0. So that's your solution. So that was our last question, guys, for this video. Thank you for watching. If you didn't subscribe, please don't forget to subscribe. Tell us how do you feel about our lesson. Comment and hit the button, that button, the ring button and notification button, so that you can get a notification updates about our channel when we have something new. And don't forget to tell your friend about our amazing channel. If you didn't subscribe, please don't forget to subscribe. Thank you.